There are lots of videos out there on how to launch a DDoS attack, but not too many go into the details. Things like, what is TCP IP? What kind of DDoS attacks are out there? How can you effectively analyze a DDoS attack? And not only that, how can you prepare the right defense for the right DDoS attack or all DDoS attacks as a cybersecurity expert? That's exactly what I want to show you in this tutorial. Go get your coffee, buckle up, and let's get learning. Of course, if you like my videos, smash that subscribe button and click on that little bell so you can get notifications as soon as more content is out. And one more thing, all the sections in this tutorial are chapterized so you can go back and forth whenever you need to. Alright, so this is the panorama for today. First, I'm going to show you what TCP IP and UDP protocols are. Then we're going to discuss DDoS attacks. So what are they? What type of DDoS attacks are there? Then we're going to set up the tools on Kali Linux, so DDoS tools. We're going to be doing a little bit of attacking to a vulnerable WordPress and Debian 10 application. We're going to do analysis using HTOP, using netstat, and also using Wireshark. And then we're going to show you how to defend yourself from DDoS attacks. The tools that we're going to use are Hulk.py, Tor's Hammer, and HPing3. At the very end, I'm going to show you more ways you can defend yourself, and then we'll have our conclusion. That is our tutorial for today. All right, so I'm going to make this as easy as possible for you. TCP, UDP, ICMP, SMB, they're all different protocols that are used on the web. TCP is the most used one, and it's the one that you see every time you go to Google, every time you go to websites, and so on. Right? So there is a relationship between the sender and the receiver. And at the very beginning, there needs to be a handshake in there. They need to connect. So each of these computers, so the sender and the client, have an IP address, obviously. So the sender, in this case, the client, or your computer, will send a SYN packet to a receiver, right? So 32 bits, it sends a ping, and the receiver is basically asking the receiver if he's there, right? So it's like, hey, are you there? And then the receiver or the host sends back a SYN ACT. It says, yes, I'm here, right? ACT is for acknowledgement. Then the sender sends back an acknowledgement saying, yes, okay, you're there. Now I'm going to send you more information. I'm going to start the data streaming. And that's how the data starts to get streamed. Back and forth from the sender to the receiver, etc. What I want you to remember about TCP handshake is that it's the most popular one, and not only that, it's the priority of the TCP handshake is reliability. That means that if there's a packet that it gets lost, then the sender is going to resend it again. And this is where DDoS attacks come in. You can have a DDoS attack right at the beginning, so when the sender sending a synchronized packet to the host, or you can have one where the sender is sending the acknowledgement packet to the host, or you can have what's called an HTML flood. So the whole handshake is already done, and now I'm starting to bombard you with HTML requests. In terms of UDP, is very similar for DDoS attacks, but the UDP transmission is completely different. There is no handshaking here. So in this case, the receiver, so for example, your computer is sending a request to the sender. Let's say YouTube, show me a video. And then YouTube sends back a response. It says, here's the video, and starts to respond. And that's the data that's coming in. As you can see, the priority is not reliability, but speed. So UDP transmissions are very important. It's the second most popular transmission protocol out there. And it has to do with, let's say, phone, video, things like that, right? Where you don't really care about the reliability, but you really care about the speed. All right, so this is super exciting. This is a typical DDoS attack. DDoS stands for Distributed denial of service. Why is it distributed? Because there is a bot master out there, so some sort of bad server who is controlling a whole whack of zombie computers, right? So that's called a botnet, right? A botnet is a network of computers that are infected. And the funny thing is, this could be your computer, this could be my computer, and not necessarily just computers. It could be a printer or any type of device that has an IP address that can be used as a zombie, right? So then what happens is we have the host here. So this is the victim. And then when the bot master wants, it can tell all the entire botnet, all the zombies, to start sending requests to the host. At the very end, you have the servers down. So if you have a website, for example, it's happened many times with different types of websites where there's a DDoS attack and they bring down the server. That, in a nutshell, is a DDoS attack. All right, Hulk.py. Hulk stands for HTTP Unbearable Load King. And basically, this is an HTTP flood, which means it does complete the TCP handshake. After it completes it, starts to bombard the host with HTTP requests. By the way, if you're a software developer, you're gonna thank me for this, because Hulk.py is a really good tool for doing stress test as part of your non-functional requirements. All right, so if you're a QA, use Hulk. Very good. So now we're going to set up the tool. We're going to do a little bit of hacking on our vulnerable WordPress application, and then we're going to do analysis and ways we can protect ourselves from Hulk. Hey guys, just so you know, this entire tutorial and everything I do in this channel is for educational purposes only. So make sure that you have a lab and you're doing this on your own enclosed space. All right, so as you can see, I have my two VMs running side by side. So I have my Kali Linux as well as my Debian 10. And if you don't know how to install Kali or Debian, I have two videos down below. One is for installing Kali on a virtual box, and the other one is installing an entire, so it's a big tutorial, I think it's about an hour long, of how to install how to set up a web penetration test environment, right? So let's do that first, and if not, just sit back and relax and enjoy the show. All right, so let's log into the Kali box, and let's also log in into Debian. Oops, sorry. There you go. Okay, now I'm going to power up my Firefox in here, and I'm going to power my activities and my terminal on my Debian. There you go. Okay, so I'm on the Debian. I'm going to type in netstat a pipe, right, for doing another bash, and then grep HTTP. So anything that is HTTP. And as soon as I powered up my Firefox, funny enough, I went to the hackable website, which is the website I set up for my Kali. On my Debian, if I do a netstat again, oh, you'll see the connection, right? So this is the connection from my Kali into my Debian, right? Now I'm going to do a top just to see how everything is faring. So CPU is pretty decent. The memory, there's a lot of free memory here. So everything looks pretty good, right? So now let's do the attack. All right, so from here, what I'm gonna do is let's set up Hulk. So in my Kali, I'm going to go into sudo su, right? And let's cd into the desktop, okay? And I already have DDoS in here, but we'll create a new one. So let's create a directory. So make dir, right? And then we're gonna call it DDoS2 ls. There it is. Let's cd into it. And you can see that there's nothing in there. And now let's download the Git, right? So it is git clone https github graphob hulk.git. Perfect. Now inside of my DDoS folder, you'll see Hulk now. So let's cd into Hulk. And inside here, you'll see that there's a Hulk.py as well as Hulk.go if you use Go and Windows. And there's also Hulk for Docker. It's pretty awesome. So now we're going to launch the attack. Okay. And so what you do here is just type in Python Hulk.py and then the web address. And now the attack has started, right? Now on my Debian, in the meantime, I'm going to do a netstat to see where we are. So netstat dot -a then pipe, and we'll see what's going on in here. There you go. All right, so as you can see, there's a lot of requests from the Kali machine. So obviously there's something very bad going on in here. Now if I do, come on, this is out of control. Let's do another terminal. Okay. For some reason, it's not stopping my process here. If we do the top, then you'll see all the www.data in here, which is massive, right? So yeah, and CPU is at 40%, and my RAM left is 3.3, so it's not too bad. So yeah, definitely something is going on in here, right? On the Kali side, let's power up Wireshark so we can analyze this thing. All right, so I'm going to click on ETH0 to start capturing all the packets. And there you go. Voila. Yeah, so this is all the transmissions. And as you can see, there's retransmissions for packets that are lost and stuff, right? Okay, so I will stop this attack right now, just so we alleviate the servers a little bit. So I'm just going to exit, and I'm going to click on stop Wireshark, so we stop capturing all the packets that we're sending. Okay, and right here you'll see send, act, as well as let me just make this a little bigger for you so you can see better. Right, so you see a syn act, an act, and sends, right? And then you'll see the streaming of the data. So this, for example, right here is a request. So this is an HTTP request, a normal HTTP request with an obfuscated hash, right? And then another one here. And then if you keep going, you'll see more. And then you see some retransmissions and some packet loss, and then more. So this is what we want to see, right? There you go. If we click on the hypertext transfer protocol, so this is layer 7, right? On the Aussie framework. Then you'll see the information that was sent. This is the headers. You can see it here, keep alive, Mozilla, and then close the connection and all of that, right? And this is the data that was sent, right? So you can see that the transmission was sent, and this is the referrer, right? And it was accepted and all of that. So there's not much to see on Wireshark in terms of Hulk, but you can see that information is being sent accordingly to the theory, right? So syn, act, and then transmitting the data. Okay, I think it'll get more exciting when we look at the other two tools, Tor's Hammer and the HPing 3. So let's kill Wireshark right now. And we're going to do two things. So the first one is initiate another attack. So sudo su Kali, and I'm going to cd into desktop Hulk or DDoS 2, and then cd into Hulk. There it is. And then I'm going to do Python in WordPress. So I'm going to initiate that, and we're going to defend. Okay, so stay with me because we're going to start defending this thing using IP tables. Okay, and let's run this into sudo su IPTables minus capital L, and you can see that there's nothing. I have no IP table set up. So let's set an IP table for this. IP tables, right? And the input is going to be A. So A stands for add, right? Input minus S. So minus S is the source, and the source is going to be 10.0.2.6, right? And jump, so minus J is for jump, which means what do we want to do? And in this case is drop. Boom. So now if we look at the IP tables, minus L, drop all connections, every single connections from 10.0.2.6 anywhere. So that's the rule that we have set up. Okay. Now, if we look at our Kali side, you'll see that the requests have stopped. There's no more request being sent. And if we go to the website, hackable website, and I click anywhere in here, now see, there you go, timeout. If you have one host doing this type of attack into, let's say, our web server, then you can stop it very quickly with the IP tables, right? If you have 100 or 10,000 hosts or clients sending requests, then it's going to be a bit different. It's going to be more challenging. I do not recommend to use Hulk because you're not anonymous. People are going to be able to find what the IP address is. So I use Hulk for stress testing and load testing and all of that stuff. Not too much for penetration testing or ethical hacking, right? If we look at the netstat, so let's go back to Debian 10. Netstat A, there's nothing, right? Nothing, no connection, right? So we stopped the attack. Now let's revert this. So if I go to Kali, and you see here that there's no more requests being sent, right? So I'm gonna kill this Hulk and try to power up WordPress, and I won't be able to do this. On the Debian side, let's remove the IP tables rule. So IP tables minus capital L, and you'll see there, right? So let's kill it. So in order to do that, we'll type in IP tables again. In this case, minus capital D for delete, right? And the input, it's going to be S, which is the source. And this is 10.0.2.6 and jump. So minus J, drop, click enter. And if I look at the IP tables again, minus L, you see that it's gone, right? And you can see here on my Kali that everything is back to normal. All right, Thor's Hammer. Thor's Hammer is a slow post attack. And I put post in there as the method, right? So Thor's Hammer uses post as the main method. In transmission, you have different methods. You have a get, you have a post, you have a put, you have delete, etc. So these are all different methods for communications. So a get, for example, is when you are requesting information from a website. So you tell get that information and it displays the HTML. A post is used, for example, when you are filling out a form. So if you are filling out a form, you type in the fields and then you click on submit, you're sending a post to the server, so the server records that information. So these are different methods for interaction with websites, specifically in APIs. So Torshammer uses a slow post method attack in the acknowledgement part of the TCP handshake. And more technically, it's a push act. I'm not going to get into more details on what a push act is, but it's right there in the acknowledgement level. And at the end, it does not complete the TCP handshake. What that means is a SYN gets sent, a SYN act gets sent back, and then the push act gets sent to the server, and it maintains the server as keep alive. Just like with Hulk, we're going to set up the attack, we're going to do the attack, and then we're going to analyze and defend against Torshammer. Now we're going to do Torshammer setup. Here on our Kali Linux, I'm going to power up my terminal again. So sudo su, and I'm going to go into my desktop and my DDoS 2 folder. So this is where I'm setting up all my denial of service attacks. If I do an ls, we'll see Hulk in there. And now I'm going to download the Torshammer git. So again, git clone, and in this case, this is going to be .fighter/Torshammer.git. So I'm cloning, and there it is. If I do an ls, I see Hulk and I see Torshammer, right? So I'm going to cd into Torshammer, right? Do an ls, and you can see here Torshammer, right? In order for me to launch an attack, Python countermeasures and then T and the website address. Now, I want you to pay attention to something. The nice thing about Torshammer is that you can use Tor to be able to be anonymous, right? So if I launch Tor, I have Tor installed, but let's install it anyways. So app update and apt install Tor. There it is, right? So let me clean this up, and then I'm going to do two things. So the first one is I'm going to split the terminal horizontally, right? So I have two terminals. I'm going to go into sudo su on the one below, and I'm going to initiate Tor. Now this makes me anonymous. Why? Because I'm using the Tor network to browse or do stuff with my Kali. And then on the one on top, we're going to initiate the attack. And the way you do that is basically calling Python again, Torshammer.py, and then typing in -t, capital T, and then small t, so minus small t, and the web address. Now, I'm not going to do this because it's not going to work for me. I can be anonymous inside of my own environment, right? So even if I do this, right? So if I start, then it's going to give me this error connecting, right? Which is unfortunate, right? So I'm going to shut this down, and then I'm going to shut my Tor down also. And I'm going to exit here, right? So exit, there you go. And I'm going to initiate my Torshammer again. Python Torshammer, get rid of this capital T, so just T, and start. There you go. Slow posting into my Debian. Now, if I go into netstat on my Debian, a pipe grep HTTP, again, I see the same thing, right? So as you can see, I'm getting attacked, right? Now, if I go into my Firefox, my hackable application, then you'll see that it's getting slower, much slower, because this attack is a bit harder, right, than Hulk. In here, I'm going to type in top, and you'll see that My CPU is running at 1.2, so it's not actually that bad, right? And then we got some WW data, right? And that's basically how Tor's hammer work. Let's now do a Wireshark to analyze it. Let me make this bigger so you can see better. And let's go into the etho. And there you go. Wait for the server to respond. And the server responds, and I do the same thing again there. So the handshake is never completely finished, right? There's no data transmission. Hulk.py actually does the transmission and finishes the handshake, and then starts to flood the server with HTTP request. Tor's hammer, on the other hand, does not finish the handshake and keeps the server alive at all times. So let me kill this Wireshark. Let's go back. And you might ask, how do we stop this attack? Well, you do it the same way, right? The same way with the IP tables. Now in the SYN flood, so when we are using HPing 3, then I'm going to show you another rate limiting tool. So because you're going to see different IP addresses coming into the network, not just one, the way you see with Tor's hammer and with Hulk. So stick around and let me show you HPing 3. 2 down, 1 to go. HPing 3 DDoS attack. So HPing 3 is a SYN flood type of attack, and it works also on ICMP and UDP protocols. So let me show you the ICMP protocol really quick. So I'm going to power up my command prompt. There you go. And I'm going to ping Google. Ping google.com. And you see this? So what I'm doing right now is I'm using the ICMP protocol to ping Google, who is replying back to me. And as you can see, it's 32 bytes and 27 milliseconds when I ping them. So this is the result. And this is not a handshake because it's not using the TCP protocol, it's using the ICMP protocol. And so this is what it does. HPing 3 sends pings as a SYN flood. Thousands, millions of SYN pings, right? Now, the cool thing about HPing 3 is that it obfuscates, or it spoofs, it tricks the host by sending a different IP address. Obviously, it does not complete the TCP handshake. And as you can see here, it sends the first packet to the host. So the host, what it does is it sends a SYN ACK to a different IP address, which is completely different from the original client. and it does that continuously. Let's set up hping3. Let's do the attack. Let's do the analysis, and then let's set up the defense. All right, last but not least, let's set up hping3. Let's run the tool. Let's do a bit of analysis, and let's see what we can do to stop the attack. All right, so on my Kali machine, I'm going to run my terminal on sudo su, and I'm going to install the tool, which is apt install hping3 -y. There you go. After it's installed, let's run the tool, right? So the first thing I need to do is by the way, hping3 -h will give you all the information that you need to know about hping3, which is pretty comprehensive. So, which is very good, okay? So now let's run the tool. So hping3, and we're gonna do a count of 7,000 maybe, right? You can do 10,000, doesn't matter. And the data size is going to be 120, okay? So the packets, each packet is going to be 120 bits, right? And this is going to be a SYN flood, so minus capital S. Then the port is going to be obviously port 80, right? You can do 443 or any other port, and it's going to be a flood, right? And the last thing is going to be a random, so rand source to spoof the IP addresses. And at the very end, we put the victim's IP address, 2.15, and we run the tool. What is the problem now? Okay, so here in rand source, I have to have 2 minuses on rand source. Perfect. There you go. It's running. Now, if I go to my Hackable website, you see that it's still working, right? And I'm pretty sure it's going to work because this is not really a hard setup. You need an entire botnet to be able to do this type of attack, right? So let's do 2 things. First of all, let's go into our Debian machine and let's look for the terminal. Okay, so write it on sudo su. There you go. And let's do a netstat. It's netstat A. And how do we do it to stop it? Now, this one is a little more complicated, right? We're not going to completely stop the attack, but we're going to limit it. Okay, so even though we run the security measure in here, the Kali is still going to have access to it to try to do a flood, a SYN flood, but it's not going to be very successful. So the way we do that is through our IP tables. So IPTABLES -L, capital L, you'll see that I have nothing, right? So now I'm going to add an input, right? So IP tables and minus capital A input, P for protocol, TCP, right? And M, which is matching the state, okay, matching the state, and then state again, new. So the state is going to be new. Okay, there you go. Let me just make this a little bigger. It's a big command. And then minus M to match the limit. Let's match the limit. And the limit is going to be, let's say 2 per second. 2 per second. Again, and I'm also going to put a limit burst. So limit burst of 2. So as soon as the same IP addresses hits it twice with the same thing, I'm going to limit it. Then minus J for jump and accept. All right. So I did that rule, and then I'm going to create another rule. So IP tables, and this one is going to be also add an input, right? And it's going to be minus P TCP. So the protocol is TCP, and match the state again, and the state is going to be new, right? And then the jump is going to be drop him. Right. So, and drop is with capital drop. If we look at our IP tables, minus capital L, you'll see this. So I'm going to accept any connection anywhere, right, where the state is new. So a new connection, but I'm going to limit it to an average of 2 per second, right? 2 connections per second. And I'm also going to burst it, right? So the burst is going to be 2. So every 2, if I see 2 right away, then I'm going to start limiting. And then I'm going to drop anywhere if the state is new again. Okay, let's run the rule and see what happens. Okay, so now I'm going to do netstat minus A pipe grep HTTP and see what happens. All right, awesome. Now I have how many connections? Probably about 15 connections, right? And if we go before, we had a lot of connections. You see that? So now I am limiting the amount of connections that I'm allowing, right? So if I do a netstat again, let's see where now I have what? 1, 2, 3, 4, 5, 6, 7, 8 connections, right? So I'm successful. I'm actually helping the cause. I'm actually not completely stopping the SYN flood because anybody is able to send a ping, right? There's nothing I can do about it. However, I'm definitely limiting the amount of SYN packets that people send me. Now, let's do that again. So let's do a netstat and see what happens. Yeah, about the same, right? So I'm definitely limiting this attack. And if I go into the Kali zone and go into my Wireshark, let's see what happens. See, I'm still sending all kinds of packets, right? Because there is no SYN act from the server. Do you see what I mean? So the SYN is being sent. So I'm pinging the server, but I'm not expecting to receive a SYN act because this is a SYN flood. There's no SYN act. There's no acknowledgement. There's no data transmission. It's at the very beginning of the handshake. So I'm sending those SYNs and I'm not expecting anything because I'm just doing my SYN flood. From the Debian side, I'm rate limiting those SYNs coming in, right? I can't completely stop it, but I definitely can limit that a lot. That concludes HPing 3. These are the ways you can defend yourself from DDoS attacks. First, we have the IP tables, and I showed you how to use IP tables to set up some sort of countermeasures. But if you want something that is more easy to use, then you can use a server-based firewall and the famous uncomplicated firewall UFW from Linux. It comes in every distribution of Linux, and we're using Debian 10, so it comes with Debian 10 as well. You need to be a little more advanced to be able to use the UFW. Same with the IP tables. But then we have the web server based tools. So for example, when you're setting up Apache, it comes with mod security. So you can set up mod securities to be able to do a lot of this stuff by itself. Then we have website based applications or plugins. So for instance, if you're using WordPress, you can use something like iThemes plugin that takes away a lot of the bots. It helps you quite a bit from the application side. And then at the very end, we have the proxy based web application firewalls. So things like Cloudflare, Akamai, they're all really good in solving this problem. Let me zoom in to the web application firewall. A web application firewall is a server. It sits beside your server. So your server is going to send an IP address to the firewall, to this firewall server, right? And that server is going to proxy the IP address and is going to show the application using another IP address. So it is using a proxy, right? So when the attacker tries to attack that IP address, so it will not be hitting your origin IP address. It's going to be hitting the other one. You can have a whole set of tools in your firewall to be able to deflect those DDoS attacks. And not only DDoS, but these firewalls are really good for common vulnerabilities and attacks such as SQL injections, cross-site scripting, bad bots, and things like that. So it will help you out quite a bit. And some of these tools are really cheap to get, right? So for example, Cloudflare, you don't even have to pay for it. You just sign up and all you have to do is just change your name server inside of your domain controller. So let's say GoDaddy domain controller or EasyDNS or what have you. Change the DNS, the name server, to point to the Cloudflare web server, and then it will do the job for you. However, like anything else in this world, there's two caveats. The first one is that they have also advanced tools that you can use and then you have to learn, right? And the second one is that it is not a fireproof way of defending against DDoS attacks. Why? Well, I'll tell you why. Because hackers are smart. They know that the IP address that you're using comes from a web application firewall such as Cloudflare. So they will dig in and they will find the origin IP address coming from your server because it is somewhere in there. And then if they find that, then they will continue to hammer your actual origin IP address. It's not about using one tool for DDoS attacks. It's using multiple of tools to be able to fortify and strengthen your server security. It takes a lot of work to do one of these tutorials, and there's so much stuff that I could included in this tutorial, but I decided not to, just to keep things simple. But if you have any questions, if you have any comments, make sure you post them in here and I'll be able to reply to you very fast. I hope to see you soon, and stay safe, stay secure.